Let's look at factorising quadratics where the coefficient of the squared term does not equal to 1. So a reminder that a quadratic is in the form ax squared plus bx plus c, where a, b and c are coefficients and x is a variable. So the example says to factorise 2x squared plus 4x minus 6. And so the method used to factorise quadratics of this form is slightly different to the method used to factorise quadratics where the squared term has a coefficient which is equal to 1. In this specific example, we notice that each of the terms have a common factor of 2. In other words, 2 goes into 2x squared, 2 goes into 4x, and 2 goes into minus 6. So in this case, we could factorize the 2 out from each of the terms to give us 2 multiplied by x squared plus 2x minus 3. So if we just look at the quadratic inside the brackets, we have x squared plus 2x minus 3. And so we're looking for two numbers that multiply to make 1 times minus 3. So that's two numbers that multiply to make minus 3 and add to make 2. So the two numbers that we're after in this case are 3 and minus 1, since 3 plus minus 1 is 2 and 3 times minus 1 is minus 3. So 3 and minus 1 is what we need, and so we can rewrite this quadratic in the following way to give us x plus 3 in brackets multiplied with x minus 1 in brackets. And so we can rewrite this to give us 2 multiplied by these two brackets now. So x plus 3 in brackets and x minus 1 in brackets. And so this quadratic can be factorized to give us 2 brackets x plus 3 brackets x minus 1. Now in this example, we could use this method to factorize this quadratic. But in specific questions that are not like this, we are not able to use this method to give us an easy quadratic to work with. And so there is a different method we use to factorize quadratics of this form called factorizing by grouping. So let's look at that method with this quadratic. So we have our quadratic here that we're trying to factorize. And so what we look for are two numbers which multiply to give us 2 times minus 6, which is minus 12. So two numbers that multiply to make minus 12 and add to make 4. And so a method we can use to find those two numbers is we can look at the factors of the number we're trying to multiply to get. So in this case, we're trying to get minus 12. So let's take the positive of that for now. And so we're looking for factors of 12 which multiply to make 12. So in this case, 4 and 3 are factors of 12 which multiply together to give us 12. Another pair of factors is 2 and 6, and another pair is 1 and 12. Since the number we're trying to multiply to get is negative, we know that in our pair, one of the numbers must be negative, so that when we multiply the two numbers together, we get a negative number. You can quite easily see then that in this first pair, 4 and 3, if one of these numbers was negative, then when we add the two numbers together, we wouldn't be able to get 4. So for instance, if we had minus 4 and positive 3, minus 4 plus 3 is minus 1. Likewise, if we had minus 3 and positive 4, then minus 3 plus 4 is 1. And both of those do not give us 4, which is what we require. So we know it can't be the first pair. For similar reasons, the last pair also does not work, since there is no way where one of these numbers is negative and we add the two numbers that we get 4. And so the pair that does work is 2 and 6. If we have negative 2 and positive 6, then negative 2 multiplied by 6 gives us minus 12, and negative 2 plus 6 gives us positive 4. So this is the pair that we require. So what we'll have in the next line is 4x, which would now be split into minus 2x and plus 6x, since minus 2x plus 6x gives us 4x. The reason we're rewriting this in the following form is so that we can factorize easily to be able to get the factorized version of this quadratic. So what we have then is 2x squared, and now we either write minus 2x or plus 6x. It doesn't matter which way around we write this, and I'll show you both methods. So let's start with minus 2x. Then after this term we would have plus 6x, and then we have the minus 6 on the end. What we now do is factorize by grouping. In other words, we look at the first two terms as one group, and we look at the second set of terms as another group. And so we factorize these one by one. And so the highest common factor of 2x squared and minus 2x is 2x, and in brackets we're left with x minus 1. So 2x times x is 2x squared, 2x times minus 1 is minus 2x. And then we're adding on, and now we look at the second set of terms. So the highest common factor of 6x and minus 6 is positive 6. And in brackets we're left with x minus 1. The key to this step is to ensure that the terms within the brackets that we end up with are both exactly the same. If they are not the same, then we can't now apply the next step, which is to factorize further. We can now factorize this further, and so we see that we have two terms in total. So the first term is 2x brackets x minus 1. The second term is 6 brackets x minus 1. Both of these two terms have x minus 1 in common. In other words, the brackets are common in both, and so we can factorize the bracket out. So we have x minus 1 in brackets, and now we have a second bracket. So what do we multiply x minus 1 with to get 2x brackets x minus 1? So that would be 2x. And what do we multiply x minus 1 with to get 6 brackets x minus 1? So that would be positive 6. And so this is one way we can factorize 2x squared plus 4x minus 6 to give us two brackets. Now if we compare our answer to what we got in the first method, we see that these expressions are very similar. Both of them have x minus 1 in common as a bracket. However, this first answer gave us 2 brackets x plus 3, which is almost 2x plus 6. The only difference is that the 2 from 2x plus 6 has been factorized out. So we could factorize this bracket further to give us x minus 1. And if we factorize the 2 out, it's like multiplying by 2 and then multiplying by whatever's left in the bracket. So in the bracket, we would have x plus 3. So 2 times x is 2x, 2 times 3 is 6. And so we can move the 2 to the front since we're multiplying all of these together. And so we end up with 2, and we can change the order. So 2 times x plus 3 in brackets multiplied with x minus 1 in brackets. And so we see we get exactly the same answer using either method. If we just go back to this step for a moment, we decided to write minus 2x first and then plus 6x afterwards. So if we were to rewrite this with 6x first and minus 2x afterwards, we would still get the same answer. So let's just look at that to ensure that we completely understand. So we have 2x squared. Instead of minus 2x, we're going to write plus 6x first, and then we have minus 2x minus 6. We're going to use the exact method as before, and so we can group these terms with these first two terms as one group and the last two terms as a second group. And so we look for the highest common factor of 2x squared and 6x. The highest common factor is 2x, so we can take that out. And in brackets, we're now left with x plus 3. So if we were to expand this out, we would get 2x squared plus 6x. Looking at the second group, we have minus 2x minus 6. So the highest common factor of both of these is minus 2. And in brackets, we're left with x plus 3. The key thing, remember, is that the terms within the bracket for both of these brackets must be the same so that we can factorize in the next step. And so that's why we took out the minus 2 and not plus 2. We can now factorize the two terms that we have here. Both of them have x plus 3 in common. So we have x plus 3 in brackets. And our second bracket is 2x minus 2. And so we now have factorized 2x squared plus 4x minus 6 to get x plus 3 brackets 2x minus 2. We can again rewrite this so that we get the same answer as we did for the previous two methods by looking at this second bracket here. Both of the terms have 2 in common, So we can factorize 2 out to give us x plus 3 multiplied by 2, and then in brackets x minus 1. So rewriting this, we have 2 multiplied by x plus 3 multiplied by x minus 1 in brackets. And so we see that all 3 of these methods give us exactly the same answer. The last 2 methods are essentially one method. All we've done is we've changed the order of the terms. So in this quadratic we had minus 2x plus 6, whereas in this one we had 6x minus 2x. And we see that using factorizing by grouping gives us exactly the same answers, regardless of the order of the terms, when we find the 2 numbers that we require to satisfy our 2 conditions for multiplication and addition when factorizing quadratics.